Hello again guys. What we're doing today is we are going to do polynomial division. Okay, we're going to look at how to reduce a cubic or even a quartic, you can use the same techniques for a quartic or more, by a linear factor. Again, you don't have to do it by a linear factor. This could be done with a quadratic factor. It just uses different technique, the same steps, but they might just go in different spots. It's just a more advanced question. There's two techniques I'm going to show you today. Okay, there's this beautiful algorithm on the left, which you should have, if you've done long division in primary school, then this should be recognizable to you, because this is just polynomial division. It uses an algorithm. What I mean by that is you follow the steps every single time and you get to your answer. Okay, so that's polynomial division. That's the first thing we'll go through. The other way, which actually is a much faster way, but only works when you know it's a factor, so you know it's completely divisible, there's no remainders, but this one on the right is faster, and it's known as equating coefficients. Okay, so I will be showing you both methods, so just remember that the right hand side works only when that they are factorizable, so that you know it's a factor. The left method works for any, including remainders and partial fractions you're trying, or improper fractions you're trying to do. So this first method is going to be polynomial division. It's just like long division like you used to do in primary school, but instead we're going to do it with algebra. Okay. The way this works is that we know we have a cubic quotient here. Okay, and we can divide it by this factor x plus 2. Okay. Now the first thing we need to do is we need to figure out what we can do, where the idea and the process is we want to end up, every step we're going to remove the highest order of our term. So in this case, the first thing we're going to look at is getting rid of the 9x cubed. So what we're going to do is we are dividing it by x plus 2, but I just want to really look at the highest order there in x plus 2, which in this case is just x, highest order term. So we're going to do 9x cubed divided by x, which is 9x squared. That means 9x squared is going to be this thing on top here, because that is this first leading term divided by the highest order of the factor. Now, this is when we're going to use our division, our long division techniques. So what we're going to do is we're going to do 9x squared times by this factor, and we're going to write this multiplication where they fit. So 9x squared times x is 9x cubed, so it's an x cubed term, so it goes underneath the x cubed term. Okay, so I've done that there. I then do 9x squared times 2, which is 18x squared, so I put it underneath the x squared term, this one here. Okay, the next thing I do, and I'm going to change colors so you can see the changes as I go through. We'll go green. I'm going to subtract this from the one above it, which will give us 9x cubed minus 9x cubed is 0. 30x squared minus 18x squared is 12x squared. And I am going to bring this down, but we'll do it in a second and I'll explain why. So now our leading term that's left over, because we've got rid of the cubic, is now our squared term. So we're going to do the same thing. We're going to do 12x squared, and we're going to divide it by our leading factor, which is leading factor term, which is x, which is going to give us 12x. So that means the next thing in our quadratic is 12x there. Alright, so same thing, I'm going to do 12x times our factor here, which is x plus 2. Hang on, I'll just put that x back in there, it disappeared for some reason. Which is going to give us, so we're going to do the same thing, 12x times x is 12x squared, and you can see that when we're going to subtract, these are going to cancel, which is perfect. And then we got 12x times 2, whoops, don't know what happened there, which is going to give us, let's do that again, times 2, which is going to give us 24x, so we'll put that underneath this x term. Now the thing is, I'm going to drag this down. So because I'm going to subtract these from each other, so I'm just going to pop this here so I know it's right there. So I need to subtract them from each other, just like long division. This is going to give us 0, which is what we want. And then we're going to have 19x minus 24x, which is minus 5x. Okay, if I did this right, I would have done that in a different color, so we'll just put that in blue. Okay, and now we've gotten rid of our cubic term, our squared term, and now we're left with a linear term. So we're going to do the same thing. We're going to do minus 5x over here. And so we're going to divide it by x, which gives us minus 5. Let's see if this works out. So we're going to put minus 5 up here as our next term. And then we're going to do the same thing. We're going to times minus 5 times by our linear factor. Now this doesn't work. This works with more than linear factors. You could actually do a quartic divided by a quadratic, and it would work the same way. It just has, when you lay them out, you just got to make sure you line up the like terms underneath each other. So we have minus 5 times x is minus 5x, and we have minus 5 times 2, which is minus 10. Again, I'm going to drag this down, and I'll notice something very special. So when I subtract these from each other, let's just go back to black to finish this off. When we subtract each of these equations from each other, because it tells us x plus 2 is a factor, it should work this way, such that minus 5 take negative 5. So that turns into minus 5 plus 5 is going to be 0. And minus 10 take minus 10, which is minus 10, ends up being plus 10, is also 0. So I know it's worked. Okay, that means that this cubic can be factorized and expressed as x plus 2. And then we've got 9x squared plus 12x minus 5. Okay, so that x plus 2 times by this is equal to that cubic that can be expressed. And now you have a linear factor, and you also have a quadratic, which both you can solve later on. The other way you could do it is this one here, which as expressed was called equating coefficients. So this one's done by the fact that I know that for a cubic, if I divide a cubic by a linear factor, I will end up with a quadratic. Okay, because when I divide a cubic by an x, so x cubed divided by x, I'll end up with x squared. Okay, and that's a really useful skill. Because if you start looking at it, we're going to use purple first. I do like purple. So I've got 9x cubed here. I know the only way I can get a x cubed term is by doing x times x squared terms. So that means that 9x squared, don't know why it's doing that, my new tablet. I know that for the x cubed terms, 9x squared will be equal to x times ax squared. So therefore 9x cubed is equal to ax cubed, which means just by looking at this you can see that a equals to 9. And just like that, we can do exactly the same with the constant, the c. Because we know that the constant here, minus 10, the only way you can get that is by a constant times a constant. So that means for my constant term. Now, I'm doing all the working, but honestly, you can do this by sight. So you can notice that because this is x, or 1x, a has to be 9. And we know that this is 2. You could probably already think what c is going to be. But I'm going to write them out. So we know that minus 10 on the left is equal to 2 times by c. We do a bit of division, so we know c is going to be equal to minus 5. Now what I'm going to do is I'm going to rewrite this, but now I'm going to I'm going to put a and c in its place. I'll skip ahead. Okay, so you'll notice now that the only thing we're missing is we're missing this b term. Okay, now the reason why you have to do it afterwards is because the constants and the highest order only happen one way, and if you've done binomial expansion, you'll notice there's other ways you can do the x squared and the x terms. So you actually use one as a check method, and you use one to find the actual answer. What I'm going to do is I'm going to use x squared as our check method. Sorry, I'm going to use my x squared to figure it out. So now on the left-hand side, it's going to be 30x squared. There is a technique where you just write the coefficients, but I'm going to write the whole terms to make it easier to follow. And then all we have to do is we have to think of how do we get x squared on the right-hand side. So the way that happens is I get x times by an x gives me an x squared term. So that's going to be b times x squared, bx squared. And the other way is I get the constant times the x squared term, so that's going to be plus 18x squared. Alright, now we do a bit of maths. I'm going to divide all this by x squared and just show our coefficients, which is what you could have jumped to as well. And you will notice by just simple subtraction, b is equal to 12. Alright. Now I'm just going to cross that out. I'm going to say b is equal to 12, and we're going to check that. So like I said, we used our x squared term to find the answer, so now we're going to use our x term, this one here, 19, to find out if we've done it all correctly. So we know this has to equal to 19x. All we have to do is think, how do we get x terms? Well, the first one is just the x times the constant. So x times minus 5 is minus 5x. And how do we get an x term with this too? Well, it would be 2 times by minus 12x, which is positive 24x. And you'll already notice that that worked out perfectly. That equals to 19x. We've done the right thing. So we just need to finish off by writing our factors. So we say our cubic is equal to x plus 2 bracket 9x squared plus 12x minus 5. Okay, and there we go. This is somewhat faster, but you have to do that check method to make sure you haven't made any errors. And it is not useful for partial fractions. This only works when you know it is going to be a factor, not when there's any remainders.